Quadratic equations are just like equations where we're trying to solve for x, but we see that there is an x squared involved somewhere in the problem, so that means we're usually going to get two different answers for x. Often factoring's involved, if not always. And so what we have here are just a bunch of examples of different types of problems that turn out to be quadratic equations. Like our first example, x squared minus 5x equals 14. That's a very standard quadratic equation. You see it's got an x squared, it's got an x term. You know you can't just get x alone, and so you see that it's a quadratic. You want to get it all to one side. You know, subtract 14, make it x squared minus 5x minus 14 equals 0, and then we solve it by factoring and getting two different equations for x. This is factors to x minus 7, x plus 2 equals 0, and then I set each factor equal to 0, where I have on the left side x minus 7 equals 0, and so I know x equals 7 when I add 7 on both sides. X plus 2 equals 0. I'm going to subtract 2 and get x equals negative 2 on both sides. So that's solving a quadratic equation. We see it involves factoring. But a lot of times other different equation types we've seen throughout the course turn into quadratics. Like we have a radical equation over here to the right. The square root of negative 2x minus 4 equals x plus 2. We know for radical equations we have to square both sides to get rid of that radical sign. On the left we just get negative 2x minus 4. On the right we have an x plus 2 squared as a binomial squared, so we need to multiply it by itself, not just square what's inside, but FOIL it out. You get x squared plus 4x plus 4. And then once I see that x squared, I want to get everything to one side, and I want to keep x squared since it's positive where it is, so I'll move these other terms, you know, plus 2x to the 4x, plus 4 to the other 4. This way I just have a 0 on one side. I get x squared plus 6x plus 8. And now I can keep it set equal to 0, but factor it. See, x plus 4, x plus 2. And when I set them each equal to 0, x plus 4 equals 0, x plus 2 equals 0, I get x equals negative 4, and x equals negative 2. And then down here I have examples of fraction equations that are going to turn out to be quadratics. The one on the left is a proportion, so we could just cross multiply. You know, x plus 4 times x is x squared plus 4x. Don't forget to distribute. 1 times 5 is 5. Get it all to one side, we get x squared plus 4x minus 5 equals 0. And then it's just like the problem above. We got to factor it, set each factor equal to 0, and so on. And then the last example is another type of fraction equation, but it's going to turn out to be a quadratic. The method I like to use for these is multiply everything by, let's see, the LCD, and that would be a combination of x and x plus 4, x and x plus 4. And if you're not sure how this goes, you can look back at the video that was on fraction equations, but now I'm going to simplify my denominators. I have x and x, that's x squared. I have a minus an x plus 4. I got to remember to distribute that negative sign, equal to a 2x. And so when I distribute that negative sign, I end up with this, all to one side, subtract 2x, x squared minus 3x minus 4 equal to 0. Factor, x minus 4x plus 1 equals 0. X minus 4 equals 0, x plus 1 equals 0. We get x equals 4, and x equals negative 1.